Hi, welcome to my video on decision theory. In this technique, we want to look at some definition of terminologies that are so encountered when you're looking at decision theory. We shall also be looking at different ways of making decisions under different conditions. The first condition shall be looking at is under conditions of uncertainty. What are the criteria that we consider when we want to make decisions under that environment? Then we shall also be looking at how to make decisions under the environment of risks. There are also a number of criteria that are considered in the literature for use. So basically, that is where we are going to look at today. But we are looking at it in the context of optimization because decision theory is one of the techniques that is heavily used in operational research. Now, as an introduction, now as we look at the definitions of some concepts in decision theory, the first terminology we look at is decision theory itself. And it's defined decision theory as just about choosing optimal alternatives. Just a process just about choosing optimal alternatives. We want to have to make a decision. So to make a decision, the process of you identifying the best choice out of the many choices or out of the many strategies you have at hand is what decision theory is all about. And so when we say decision alternatives, we are talking of available options. Those are the available options a decision maker can choose from. And so in decision theory, we want to get to choose the best out of it. And then one thing, even as we make these choices, we say that it's always assumed that a decision maker can only select one of these decision alternatives. So you only make one. And then when you make the decisions, you'll be encountering what we call states of nature or outcomes. Each of those decision alternatives go through what we call the states of nature. And states of nature are events whose occurrences actually determine the level of success of a course of action, but are beyond the control of a decision maker. I can highlight this better using a table in decision theory that we call a payoff table. And so a payoff table is just a table, a two-way table that comprises of states of nature and some decision alternative or strategies. Like what I've displayed here, whatever I'm talking of these investment options, whether somebody may want to invest in bonds or stocks or mutual funds, these are what we call decision alternatives. And whatever I'm talking of now, these are now the states of nature, whatever I call the economy. You are looking at how each of these decision alternatives will behave when the economy is growing, when the economy is stable, when the economy is declining. So these are the states of nature or conditions that will actually affect each of these decision alternatives. So these are states of nature. So a two-way table having the rows as the decision alternatives and the columns as the different states of nature, then it's called a decision table or payable table, because whatever we have inside here would be the returns that each of these decision alternative or each of these investment option will actually fetch if you invest in any one of them. For example, if you invest in bonds, then you expect that when the economy is growing, it will be fetching, let's say 40, if the units are dollars, $40 probably per month as profit. And then when the economy is stable, it will be fetching about $45 as profit. And when the economy is declining, you find that it will be fetching only $5 as profit. When you check stocks, it will be fetching $70 as profit when the economy is growing. And when the economy is stable, it will be fetching 30, and when the economy is declining, we'll actually be making a loss of $13. That's why the negative side. So the negative, we're talking of a loss. So this could be returns or profits or output, and so on. So that's where we are calling them payoffs. And so that's basically what we are going to be looking at. How do we now make a decision on which of these decision alternatives to choose? Because we want the best. We are talking of the optimal. And the optimal now, whenever we are making a choice, if we choose bonds or stocks or mutual funds, there must be a criteria that guides us to make that. And so we are going to be looking at different criteria that guide one, a decision maker, to make a decision on the best decision alternative, and that can choose based on these prevailing conditions. And of course, we are now going to be looking at now in the context of when we are talking of uncertainty, and when we are talking of the context of risks, when the difference is that the condition of when the conditions of uncertainty, we are looking at environment when we do not have any prior probabilities of the likelihood of these states of nature appearing. But when the probabilities are present, then we talk of conditions of risk. And we are going to look at those two case scenarios here. So we begin by looking at decision making under conditions of uncertainty. And as we have said, of course, we expect there to be states of nature will occur. But then we are saying that the decision maker does not have an idea of the probabilities of the various states of nature. But so for us to make now a decision on the best option, we make use of this commonly practiced criteria. One of them is the Maximax criterion, which is also called the optimism. There is the Maximin, there is the Laplace, there is the Hurwicz, and there is the Minimax regret criterion. So these are the commonly practiced criteria for helping in making decisions under conditions of uncertainty. And uncertainty here, we are talking of probabilities of the various states of nature or various outcomes are unknown. Now, let's begin looking at one by one. The Maximax criterion, I'll use the same example to illustrate this, which we are saying is also called the optimism. It is said that decision makers who are optimistic in nature are the ones who embrace the Maximax criterion. And what this criterion seeks to do is to maximize the maximum payoffs. Remember, the payoffs is actually what those values you are seeing in the cells. And so we are saying that the Maximax criterion wants to maximize these payoffs, sometimes called the best of best. And when you look at these alternatives, what it does is that it looks at each decision alternative one at a time. For bonds, it looks at bonds, the highest it can fetch under the three prevailing conditions is 45. So it picks 45 as the best. Then stocks, when you check the stocks across the prevailing conditions, the best is 70. When you check the mutual funds, the base is 53. And so we have all those three. So we create a column at the end of it all where we have checked the best payoff for each decision alternative. Then now out of this best, we now get the most best for the superior one. And the superior one, you can see 70 is higher than the rest. And so because 70 now corresponds to stocks, now a decision maker who is using Maximax criterion will make a decision now to invest in stocks because stocks has the highest maximum payoffs comparatively to the rest. So somebody will invest now in stocks because of that, based on that criterion. We talk of optimistic, they only look at the best scenarios only. Now, we look at now the opposite guy, who is a Maximin. Maximin is now, we talk of a pessimistic or a conservative approach. These are fellas who fear making losses. And so for such guys, they look at the worst scenarios. So for each investment opportunity, they look at the worst scenarios. Bonds, the worst scenarios when it's fetching you five, let's say dollars. And stocks, the worst scenarios when giving you a loss of negative 13. And mutual funds is when it's giving you negative 5. So out of these worst scenarios, what is the best? The best scenario, in other words, where do you feel the less hit is actually this when you're getting $5. You rather be getting $5 rather than getting a loss of 13 or a loss of 5. You rather get a profit of 5. So that means based on Maximin criterion, one would opt now to invest in bonds because bonds gives us the best worst payoff. So invest in bonds, that becomes a decision. So the decision to invest in bonds will be now based on that particular criteria of a pessimistic decision maker or pessimism. The next criterion under this environment of uncertainty is Laplace criterion. And with the Laplace criterion, this criteria assumes that all states of nature are equally likely. So when you look at this particular example, where we have the three states of nature, when the economy is growing, when the economy is stable, and when the economy is declining, we are assuming they're equally likely. And so we are not going to have one state of nature being maybe domineering over the other. So what happens is that using Laplace criterion, for you to make a decision, just get the average of the payoffs for each decision alternative. So that now for bonds, we take 40 plus 45 plus 5, and because they are 3, we divide by 3. That gives us 30. For stocks, we have 70 plus 30 plus negative 13. Divided by 3, we have 29. And for mutual funds, again, we sum the 3 divided by 3, we get 31. And so when you now look at these average outcomes based on Laplace, we now select the alternative that is associated with the maximum payoffs. You can see here the one associated with the maximum payoff is this one of mutual funds, which is giving us 31 as the highest average. And so based on Laplace criterion, one would now seek to invest in mutual funds because of it has given us the maximum payoffs on average compared to the rest of the decision alternatives. The next criteria is called Hurwicz criterion, or what is sometimes called the realism, or also called the weighted average criterion. Now, this one is a compromise between the Maximax and the Maximin decision criteria. It looks at both the Maximaxi, where those people are very optimistic, and the Maximin who are pessimistic, and tries to get a bridge of the two. So that now we are saying the concept allows the decision maker to take into account both the maximum and the minimum of each alternative and assign them weights according to his degree of optimism or pessimism. Now, what happens is this, that once we have a payoff table with the alternatives given and the different states defined, we look at it that if we are looking at in the context of Maximaxi, then under bonds, the best is 45, under stocks, the best is 70, and under mutual funds, the best is 53. But if you are looking at the context of Maximini, then the worst scenario under bonds is 5, the worst scenario under stocks is negative 13, the worst scenario under mutual funds is negative 5. And so we have the two. But now, what Hurwicz criteria now does is that looks at between the optimism and pessimism and decides that maybe there is more likely of maybe getting the best outcomes. Optimism or the Maximax is more likely than the Maximini, and so assigns a coefficient or a weight more on optimism than pessimism. For example, when I'm talking of a weight is a proportion, and proportion sum up to 1. And so let's say he assigns a coefficient of optimism to be 0.8, that alpha is 0.8. And so the pessimism will actually be the complement, which will be 1 minus 0.8 to be 0.2. Then uses that to get what we are calling now the weighted average. This is now the weighted average. And so how are they getting 37? 37 is obtained by 0.8 times 45 plus 0.2 times 5. So if I have 45 times 0.8, then plus 5 times 0.2, that's what is giving us 37. And then the next one, I'm talking of 70 times 0.8 plus negative 13 times 0.2. And that's what is giving us 53.4. And so that's how we are calculating now these weighted averages. And now what this Hurwicz criterion now does is that the alternative which maximizes the sum of the weighted payoffs is then selected. So we look at among these weighted averages, which one is the maximum? It's actually 53.4, which is maximum. So if 53.4 is the maximum, we now select the alternative corresponding to that, and that is stocks. So based on Hurwicz criterion for this kind of decision table, one will make a choice to invest in stocks. Then the Minimax regret approach. Now the Minimax regret approach, it actually minimizes the maximum regret. And the regret here, we also talk of opportunity loss. And so what we need first is to construct a regret table. And how do we construct a regret table? We look at each state individually. Like during the economy, when the economy is growing, we look at when the economy is growing, the highest payoff is actually 70. And so during that time, and so somebody who has invested in stocks has no regret because he's fetching the highest during that season. So the regret here will be 70 minus 70, which gives you a 0. Which gives you a 0. And then, but then the one who has invested in bonds during that particular season will somehow be regretting because he's fetching 40 when the counterpart, the highest counterpart in that during that season is fetching 70. So we'll be having a regret of that. So how are we getting a regret there? Is the highest during that particular season minus 40, which is giving you that. And then the mutual funds, the regret here will be now 70 minus 53, which will be 17. So that will be the highest regret for one who has invested in mutual funds during that season. However, when the season is stable or the economy is stable, the highest payoff during that season is 45. And so here we can see the regret will be 0. The regret also under mutual funds will be 0. But the one who is invested in stocks will be regretting, be having actually 45 minus that. So the regret here will be actually 15. The regret there will actually be 15 because it's fetching 30 when others are fetching, let's say $45. Then when the economy is declining, we see the one who is fetching highest is this one of 5 in bonds. And so the regret here will be 0. But the regret for stocks will now be that 5 minus negative 13, and this will now be 18. And the regret now for mutual funds will be that 5 minus that, and that will be 10. So once you have constructed a regret table, and a regret table when you construct will appear now as what we can be able to see here now. It appears this, so that we are now having the 30, the 0, the 17, and then we are now having the 0, 15 is 0, and so on. So we are calling it maximum regret. So we now check in each decision alternative, what is the maximum? When you look at bonds, 30, 0, 0, the maximum is 30. This under stocks, the maximum is regret is between 0, 15, and 18 is actually 18. And then under mutual funds, the maximum regret is actually 17. That's the opportunity loss. Now, we have said that the Minimax regret, so we have constructed the regret table, and we have created a column for maximum regrets per decision. Now we want to check the minimum of this maximum regret. That's why we are saying Minimax regret approach minimizes the maximum regret. So from that column of maximum regrets per decision variable, we identify the minimum from this, so that we call it Minimax regret. And the minimum here is 17, and 17 corresponds to mutual funds. And so somebody using Minimax regret criterion to make a decision on which investment option will choose to invest in mutual funds based on that criteria. So those are now the criteria used when you're making decisions under the conditions of uncertainty. Now we want to look at how do we then make decisions under conditions of risk. And conditions of risk, you have said here that the probabilities associated with the states of nature are now known. So you have some more information here. And you're saying these probabilities could be obtained either from past records or from just subjective judgment of the decision maker. Now, there are commonly three decisions here, criteria that we use. There is what we call the expected monetary value. There is the expected value of perfect information, and there is the expected regret criterion or expected opportunity loss criterion. So those are the three criteria now that we make use when we are making decisions under conditions of risk. We begin looking at the first one where we are looking at expected monetary value criterion. We are saying this one simply seeks to maximize the expected profit. That's to maximize the expected profit. And so how do we do that? We first of all calculate the expected value of each decision alternative, and then which is the sum of actually the weighted payoffs for that alternative. I'll explain how we do this. For example, if we look at the same example, if I want, the table is normal, but we have now been given the probability. You can see the probability that the economy will be growing is 0.25. The probability that the economy will be stable is 0.3. The probability that the economy will be declining is 0.45. One thing we must make sure is that it's always good to check that the sum of these probabilities for the given states of nature is actually equal to 1, it should sum up to 1. Otherwise, if it doesn't sum up to 1, then somewhere there could be a problem. Now, one thing we are doing here now under expected monetary value is that we calculate the expected monetary value associated with each decision alternative. Now, if I want to calculate the expected monetary value, that's EMV, for bonds, I talk of 40 times 0.25 plus 45 times 0.3 times 5, okay, plus 5 times 0.45. That's what I mean, 40 times 0.25 plus 45 times 0.3 plus 5 times 0.45. And that is what gives us 25.75. That's what gives us 25.75. I do the same for stocks. If I want to get the expected monetary value for stocks, it will be 70 times 0.25 plus 30 times 0.3 plus negative 13 times 0.45, and that's what is giving us 20.75. 2.65. We do the same for mutual funds, and you're able to get those expected monetary value. Now, according to the expected monetary value criteria, the criteria seeks to maximize the expected profit. Remember, this is now the expected profit for each decision alternative given. So you will choose the one that gives you the maximum, of course, and the maximum here is 25.75, corresponding to bonds. So based on expected monetary value criterion, our decision maker here will choose to invest in bonds because it will give you the highest expected profit from the three investments. And so that has been obtained by calculating the expected value associated with each decision alternative. Now, expected value of perfect information. Expected value of perfect information is actually given by this equation, where the expected value of perfect information is given by, this is now the expected, we call the long run average return if you have perfect information, or the expected return if we have with perfect information, then minus now the maximum of the expected monetary value that we have just obtained in the previous example. So if we get the maximum of this, subtract now from, it is always not expected that with perfect information, you will fetch higher returns than just based on maybe the expected monetary value. So that difference is what now gives you the expected value for perfect information. And so this particular figure will now be giving you a guide on if you were to source maybe for some more information or consultants or training so that you get more returns. It gives you a guide on how much you need maybe to set aside for that. Let's use an example here to be able to calculate that. We have already seen that with this example, we can be able to get the expected value, expected monetary value associated with each of those decision alternatives. That's 25.75, and 20.65, and 24.5. And based on this particular figures, we said that 25.75 is actually the maximum expected value. And so based on expected monetary value, one will invest in bonds. But now with these figures, how do I now get the expected payoff with perfect information? Now, expected payoff with perfect information. Now, with perfect information, if I'm looking at when the economy is growing with perfect information, one will go for the maximum here, 70. Yeah, so that if you have perfect information, you'll go for a particular decision alternative that is fetching highest during that season. And then with perfect information, when the economy is stable, you'll either go for this one or even this lower one. And the expected payoff with perfect information when the state is declining, you'll go for one that's giving you highest during that particular season. And so how do I calculate now the total expected payoff with perfect information for the three states, whatever I'm calling EVWPI? It will be this 70 times the probability during that season, 0.25, 45 times that probability during that particular season of economy, 0.3, then 5 times that. So when we have those three and we sum, we are saying that with perfect information, then this will be the return in terms of profit. If they are dollars, is that 3.25. You can see is actually higher than without perfect information, just based on expected monetary value, we are getting 25.75. So the difference is now what we are now calling the difference between that value is what we are now calling the expected value of perfect information. So the expected value of perfect information is now at 3.25 minus 25.75, which is $7.5. So if you were to seek consultants so that you have perfect information before you make the investment, then you should not spend more than $7.5 for consultants or for training to have the perfect information. So 7.5 becomes like the limit. And then lastly, we have the expected regret criterion, which is more like the Minimax regret criterion that we saw under the environment of uncertainty. So this is the equivalent under the environment of risk. So we have said the expected regret criterion, also called expected opportunity loss. It seeks to minimize actually this expected loss. Just like we had under the Minimax regret criterion, we were seeking to actually minimize that maximum regret. So the same thing. So that now we calculate again now the expected losses per each of these decision alternatives. So we use the regret table. This is the same regret table that we had created before for this problem. The same regret table, so that this is 30, this is 70 minus 70, 0, this is 70 minus 53, 17. The regret here 0, 30 is 15, this is 0. So the same regret table that we had created earlier on. And so we are saying that now with the same regret table, we can now calculate the expected loss for bonds. So 30 times 0.25, that's 30 times 0.25. Then plus 0 times 0.3 plus 0 times 0.45. So this gives us 7.5. Then we also calculate the expected loss for stocks. It will be 0 times 0.25. Then 15 plus 15 times 0.3. Then plus 18 times 0.45. And that gives us 12.6. And we do the same for mutual funds. So we get the three sets of values of expected loss. And now we look at these three, which one is the minimum? Because we want to invest in a decision or in an investment option that gives us the minimum loss. And so the minimum expected loss, 7.5 is the lowest and corresponds to bonds. So based on the expected regret criterion, then one will opt to invest in bonds. And so that is how we carry out decisions under the environment of uncertainty and under the environment of risk as far as decision theory is concerned. Thank you so much.